Welcome, ladies and gentlemen, to another session on blockchain. Now that we know the fundamentals of blockchain, also we went through the use cases of blockchain, it is time to get our hands dirty. In my Bay of Blockchain session, that is Bitcoin and Ethereum of blockchain session, I stated that in Bitcoin world, the scope was only limited to Bitcoin transactions. However, with the advent of Ethereum, and smart contracts through Ethereum, flexibility was provided to put one's business logic in blockchain. With smart contracts, self-executing computer programs can be written which can enable transactions, business, asset transfer, and variety of other use cases. In this session, we will be coding a simple smart contract in an online coding interface, Remix, in a language called Solidity. It is a Turing-complete language, meaning it has functionality and syntax very much similar to other coding languages. So for us developers, it is easier to ramp up faster in this technology. Remix gives a platform for development, deployment, testing of smart contracts, and it creates a file with .sol extension. That's why I have named this session as Sol of Smart Contracts. Moving on. I am Jitin Fernandez. I have 12 years of experience in IT industry. I am PMP certified IT project manager based out of Dubai. I am blockchain certified and take a lot of interest in this technology. As a prerequisite for this session, you should have knowledge about coding, basic concepts of coding, OOPS concepts, etc. Also, I would recommend you to go ahead and see my first two videos, that is blockchain introduction and pay of blockchain, that is Bitcoin and Ethereum of blockchain sessions, to understand this better. Moving on. So this is our problem statement against which we are going to code. So our smart contract should do the following. Should have a capability of enabling an individual or organization to open a bank, and to open a bank, non-refundable deposit of 50 Ether must be made. So I'm going to the browser. Like I said, remixethereum.org is where we will be coding Solidity samples. As you can see, there are few samples already. You can select the environment. I'm selecting Solidity, and I will go ahead and create a file. Since this is our sample and we are creating a bank, we will call it as Ether Bank. Now, the first syntax for this is you have to instantiate the Solidity version which we are working on. Since Solidity is a new language, there are a lot of versions which are coming up and the syntax keeps changing. So it's not a drastic change, but certain syntaxes keep changing. So what I'm stating here is I will be coding in Solidity from version 0.4.22 and it would be until version 0.6.0. Okay, now you have to just mention your contract, that is Etherbank, and like you do in other programming languages, you put curly braces. We would need an address parameter. Like I said, in blockchain world, you will have addresses, you will have public address. So we need to know who the owner of this bank is, and we have given an accessibility of private, so it will be accessible only within this contract. Now it said it should allow an individual to open a bank if it has only 50 Ether, meaning whenever you instantiate this contract, the constructor should enforce this. So we are coding a constructor. Okay, very similar. Uh, and you mention here payable, stating this particular contract when initiated, you have to deposit money to this contract. Now you want to enforce when an individual or an organization is opening a bank, it should put in 50 ether. So I use the require. Whenever you are dealing with smart contracts, you have an inbuilt parameter called message, MSG. It has attributes value. So we will check whether the value when that individual is trying to open a bank has 50 ethers with him. And if he doesn't have, we will say minimum 50 ether needed to open a bank. Now, if this message gets validated, in that case, we will assign the owner with the other parameter, which is the sender. Okay. Now, okay. So we have coded the first option. Next one is facility should be given to enroll to the bank, and to attract initial customers, an introductory offer of 5 ether should be given to first two individuals. So now people can enroll to this bank. So you should firstly know that how many customers have enrolled to this bank. So we will create one integer parameter which is unsigned, meaning it won't have a negative value. It and the number of customers will always be 0 or a positive number. So that's why it is unsigned integer. Also, one more thing is every address should be linked to a balance. So we do it using a mapping parameter. So in mapping, what we say is each address will be linked to an unsigned integer and it will hold the balance of that particular customer. And also, you would like that whenever an account is credited, you want to inform the consuming application. It can be a web application which is outside the Ethereum world. So we have events which can be emitted. So whenever the account is credited, I will inform an event which will capture the account address and will capture the amount which was credited. Now I have put this keyword indexed here, like in our Microsoft SQL database, indexing helps to retrieve details faster. So similar concept here. Now we will go ahead and call a function called enroll. So very much similar syntax. Enroll to bank. Now we want this to be public as this will be invoked from outside. Whenever we enroll to bank, we will return his or her balance. Now, the condition said that 5 ether should be given to first two individuals. So we will check how many customers are enrolled to bank. If number of customer is less than 2, we will give 5 ethers. So we'll increase the customer count. This is very much similar with other coding languages, and we will give that customer, whoever is enrolling to the bank, with a balance of 5 ether. Okay, and then we go ahead and return the customer balance. If you are not the first two customer, then you won't get 5 ether. You will just have a balance of 0 returned when you enroll to the bank. Now you can see that I have put number of customers plus plus here. Let me instantiate it in the constructor. Okay. So one more function down. Let's see the next requirement. An individual should be able to deposit, withdraw, and check his balance. So now we will create a function for deposit. Okay, so again we will call it as public, and since we are giving money to this smart contract, we will have payable keyword here, and it will again return the balance. So customer balance for that particular account, that is message.sender's account, should be added with whatever value he is depositing. Now if you see here, we are not passing the amount that is getting deposited as an input parameter. Like I told you earlier, whenever you invoke a smart contract, you are sending message.value, that is nothing but the amount you are depositing in this contract. So we will put message.value. If plus equal to is nothing but you are adding customer balance plus the message value and assigning it to customer balance back. And remember, we had created an event, so we are going to emit the event out, which is account credited with the address and the amount credited, that is the value. Now this can be used by the consuming application maybe to send an SMS saying this much amount is credited in this account. Okay, so deposit is done. Now we will go ahead and write the withdraw function. Now you will have an input parameter because you are not sending a money to this contract, you are removing amount from your account. So that's why we won't be using message.value here, and it will return remaining balance. First principle for withdraw is you can only withdraw the amount equal to or less than the amount in your account. So we will check that. So we are checking the balance in this guy's account is less than that. We go ahead and withdraw. So when you withdraw that amount, the balance should be deducted from that particular user account. So we are deducting that amount. After deducting the amount from the bank, it has to be credited to the user who's invoking this function. So we will be saying message.sender dot transfer function. This is an inbuilt function available with withdraw amount, and then we will just return whatever balance is left. So we have the withdraw function also coded in. We have to have a function to check the balance. Again, public. Now we are using a view because we won't be doing anything else. The view keyword is used to inform smart contract that there is no processing and you shouldn't be charging a gas amount for performing this transaction. So it is return customer balance for that sender. So this is how you can check balance. It will return what balance is there in the account. Now let's see. Bank should be able to check number of people enrolled to the bank. It's again a simple function. Check total count. Again, we will use view. Okay, and we will just say return number of customer. That's it. Our sample bank is ready. we have to go ahead and compile and then deploy the smart contract. So we'll see that. You have to come here in when you see this icon and just click on this. Now it will give you the error. Let's compile and see. Parser error. Okay, there is some validation which we are missing. Here it should be returns, and when you return, it should be return. So that's the one. Okay, let's see now where else there is an error. See, this red shows there is an error. There is spelling mistake here. So that might be it. Oh, in deposit, we didn't return the balance. So we will just return the balance of that particular customer. Okay, so that's fine. I see that the spelling is wrong here, so I'll just fix that. Okay, so the compiling is done. So we don't have any more errors. So we went ahead and fixed all of them. Next thing what we have to do is we have to go ahead and deploy. I went ahead and deployed, but it didn't allow me. If you see, there is an error and it stated that minimum 50 ether is needed to open the bank. So I will go ahead and provide 50 ethers. Well, these are all different values of ether, like we have fills and dollars. There is V, GUI, so on and so forth, and ether. So we just select 50 ethers, and again we go ahead and deploy. This is the address from where it is getting invoked. So now we got a success saying that the contract is deployed. And if you go ahead and see, we have all these functions here. So let's go ahead and enroll to the bank. So when I go ahead and enroll to the bank, I see that the transaction is succeeded, and let's go ahead and check the balance. So I have balance of 5 ethers. So there are number of zeros here because ether is the highest currency here. Now let's go ahead and withdraw an amount. So I will say I'll withdraw maybe 500,000. So I go ahead and click on withdraw. I see that it's successful. Okay, I will check the balance. You can see that is deducted from my account. So this is how you deploy the smart contract and you go ahead and test it in Ethereum world. And if you see coding smart contracts, deploying them, testing them, using this interface is very easy. So we have our first smart contract in place. Now that's an achievement. So to summarize, a simple smart contract is being created using Solidity, and we tested it as well. In the next session, what we'll do is we will create another sample with advanced features in smart contract world. Also, we will go ahead and integrate the smart contract with Jack's wallet, and we will see how both of them marry together. So that's it from my end. Thank you very much. Have a great day. Bye.